This is for Westlake High School in Dawson Oaks. It's a related rates problem, question number 8. Okay. It says a pebble is dropped into a pond, causing a ripple. A measuring device indicates that at the time the radius of circular ripple is 5 inches. The radius is changing at a rate of 2 inches per second. How fast is the area changing at the time? So how do we do like related rates problem? The key is rate right there. Let's look at what a rate is by definition, or some units of rate. It could be miles per hour. It could be feet per second. It could be how the area is changing per day. It could be how many houses you're building per year. So what's the common denominator? Hour, second, day, year, it's always going to be per unit of time. Something per unit of time is by definition called a rate. Okay, so let's get some values like A is for area, H is for height, it could be R is for radius. What else is there? V is for volume. So there's always all these different types of things as well. Okay, for different letters that we use for different variables. Okay, so we're going to take a look at this problem right here. Into a pond causing a ripple. What kind of ripples are these? So when you drop a pebble into a pond, the pond doesn't come out like squares, right? No, as it ripples through. We definitely don't see that, right? So what happens when we drop a pebble in the pond is make circular ripples, right? Bigger and bigger and bigger. And these areas are circles, right? So the area of a circle is equal to pi r squared. And there it is. When you take the derivative of a, we end up, or respect to time, of course, you end up with dA dt. If we take the derivative with respect to time of r squared, the derivative of r squared is going to be just 2r, because using the power rule, we take the 2, bring it on down, subtract 1, 2r, times the chain portion. The derivative with respect to time of r, that's just going to be dr dt. So don't forget, if you take the derivative of, let's say, respect to time of p to the 7th power, it's going to be 7p to the 6th times dp dt. But that's the chain portion right over there. Okay, so that's some information that's kind of useful at this stage. All right, we might do a little bit harder question. I'm not quite sure yet, because I noticed that there was some extra harder question as well. So let's analyze this information and then write it in words. A measuring device indicates at time radius is 5 inches. It says at our radius equals 5. Radius is changing at a rate of 2 inches per second. The radius is changing dr over dt, the instantaneous change of radius with respect to the instantaneous change of time. That's going to equal 2 inches per second. That's going to be something that's important. So we know that the area of a circle is equal to pi r squared. What we're going to do is I'm going to use red pen right now. I'm going to take the derivative with respect to time of the left side as well as the right side. The derivative of a respect to time is going to be dA dt. The derivative of pi r squared with respect to r is going to be, we're going to factor out pi first, and then take the derivative with respect to time of r squared. We talked about this a little bit earlier. Pi times the derivative of r squared was 2r times dr dt. This is something that you're going to have to get used to. They give you, oh, by the way, we're trying to figure out how the area is changing, right? dA dt is what we're trying to figure out. How the area is changing with respect to the time, because time is of the essence. dA over dt is equal to pi times 2 times the radius. Now we can put in the radius at this stage. After you take the derivative, you can figure out what r was, which was 5. dr dt, it's increasing at 2 seconds, 2 inches per second. And it's going to be 2 times 5 is 10 times 2 is 20 pi. That's how the area is changing with respect to time. And let's take a little bit, that's our final answer. The area is going to be in inches squared per time. Time is in seconds. Square inches per second, okay? Let's look at this value a little bit. Why is the radius changing with respect to time a constant? Well, as it gets bigger and bigger and bigger, right, as time goes by, the ripple's not increasing faster. No, it's or it's not slowing down, right, and stopping. It's actually going at a constant rate. That's the reason why it's always going to be usually in a constant of 2 inch every second. Okay, I think that was the answer. I haven't actually checked it yet. It's 20 pi inch squared per second. Good luck on your homework and good luck on your exam.